hope so. Good evening, everybody. Afternoon, evening. In American, this is evening, and I guess this is still miłego dnia. Yeah? Welcome to WarsawJS Meetup number 103. And we're really happy today and privileged and pleased to be here at the headquarters of PackHelp, one of our sponsors. Give them a hand. Yeah. Hey, Daniel. It's a very comfortable environment, wow, actually the most comfortable environment that I remember us being in. And they've been nice enough to let us be here today. So sit back, enjoy yourselves, and get ready for some really, really good talks. We will also be live streaming today on our YouTube station. So we invite you afterward to come and check it if you want to watch the entire meetup, or send your friends or recommend your friends to check out what goes on here. We would really appreciate that. Comment and also like. The same applies to our Facebook page. So visit us on Facebook, like everything that you see. It really helps us to gain some kind of organic support. Our WarsawJS Meetup team includes Piotr Jentara. He's somewhere in the room. I hear him howling. There he is back there. And we have Sasha, without whom none of this would be able to happen. Maciek. Why can't I ever remember his name when I'm standing here? Machniewski. Maciek Machniewski. If you're out there, you know, of course you know that I know your name. It's just that for some reason when I'm standing here, I go, Maciek, and then I forget your last name. We love you. He also helps us in social media. And Barry Salone, I will be your master of ceremonies this evening. In addition, one of the greatest loves of my life, Louise Haas is our technical master. We call her the mechanic. And she makes all of these things coordinate and work together. In addition, we have our volunteers, Amedi, oh boy, here we go. Davudbek? Is that good? He's here, I saw him here earlier. And Grzegorz Markowski. Give the volunteers a hand also. It's impossible for us to make this work without a lot more help. And if you're interested in volunteering to help us put some of this stuff together, including and up to Confront.js, the next one, we certainly welcome you. Yush, that's enough time? He can't control himself. All right, so what is WarsawJS? I'm going to read this verbatim as I do each time. WarsawJS exists to support both professional and novice software developers within the IT community. We intend to accelerate the process of education by sharing our knowledge and experience. This sharing of knowledge is something I encourage you to do. Each one teach one, grab a child, teach them something about programming and development, because they're not doing a very good job of that in the schools these days. So we really could use you guys' help, and you guys know what you're doing. Our mission statement basically includes this Berlin Code of Conduct. I don't think this is necessary. I'll do it anyway. We really like to encourage respectful interactions between ourselves, meaning no offensive language, no discrimination based on race, religion, nationality, sex, gender, or personal preferences. And we really would appreciate it if everyone would abide by those rules. So far, we've had no problems. Does everyone agree that we should conduct ourselves in that way? Let me see your hands. All right, you can clap them too. Great. Yeah, one time we were doing that and some person was sitting there like, and I thought, oh, maybe he didn't hear me. I'm not really sure. What's happening now? This is start a new group. What's this about, Piotr? It's good. Well, we know it's good. We have over 6,000 members, as I'm sure you know. And this page was, I found it very 6,212 members. And, you know, I guess we're encouraging you to invite people to join us because this is an ever-growing and vibrant community. WarsawJS.com is our website. If you want to know more about how we work and who's involved, please do visit the website and you can contact us there. Our sponsors today, and this is where we really need your help, guys, because this is the energy comes from here. Just start clapping now. Fresha, PackHelp, Utility Warehouse, and Xfang. Right, because without these folks, believe me, we would not be drinking this beer and sitting here so comfortably, we'd be outside on the sidewalk. We really, really appreciate all the support that we get from our sponsors, and PalCup has been a continual sponsor of WarsawJS workshops included. Finally, if anyone wants to give a lightning talk today, a lightning talk is a 5-minute talk. Most of the talks will be 25 minutes today, and for our speakers, this is a good time to inform you that we really mean 25 minutes, so we hope that your information will be condensed and organized in such a way that you will be clear and concise, and I won't have to ring the gong, because you're going to, unfortunately, if you go over, you'll hear a sound that is not the most pleasant sound, and that will just be to remind you that your time is coming to near an end. If you would like to give a lightning talk for 5 minutes, you have an opportunity to win a JetBrains license. Let me see, what's the license? A 100% discount for a 1-year JetBrains license. So, if anyone's interested in giving a lightning talk, either speak to myself or to Louisa or to Piotr Jentara or to Sasha Michałowska and let us know. It's not that painful. I mean, it's a very easy audience, as you can see. So, you know, you can't go wrong. Just introduce the topic, talk a little bit about what you do or something you want to talk about, and maybe you have a product to advertise that happens from time to time, that people do sales up here in recruiting. 5 minutes, and you can win that license. Finally, we're on to our first speaker of the evening. And our first speaker is Rafał Pocztarski. Now, we've met before. Rafał, where are you? There you go. Directions of development that we should all keep in mind at every stage of our careers. Sounds pretty serious. The stage is yours.
I know. Piotr, did you?
They've got you loaded.
Okay.
Give a big hand again, everybody. Welcome, Rafał.
Hello? Okay, I don't want to, you know, mess anything on your computer, so. Oh, okay, if I can take it, it will be much. Okay, thanks. Okay, so my talk today is less technical than usual, so I hope that it will be still interesting. It's titled Senior and What's Next. So I will have to check if I can use this. Okay, so a bit about me. My name is Rafał Pocztarski. I am staff backend engineer at RAMP, and some of you may recognize me from Stack Overflow because it's common that when I speak, people don't recognize me personally, but some people recognize my avatar from Stack Overflow because I happen to write quite a lot, especially in the early days of Node.js. So I wrote quite a bit of answers that some people recognize. So that's always nice to me if anyone find them helpful. And senior and what's next. So this is something that I would like to share with anyone who is a senior software developer, or maybe who is even a junior and would like to know what can happen later in the career, because usually people start as juniors. I know people who started as seniors, but it's common that people start as junior, and junior usually should be told what to do and how to do. So when someone starts working at some company, usually everything is clear what should be done, and there is always someone who can help a junior to know what the developer should learn, what the work will be, and usually this is like very suited for what the company is doing. And junior should also know how to become a mid software developer in a given company. So it should be clear what should be achieved. And life is easy, of course, not really, but because a junior developer usually knows what to do, but not always knows what he's doing. So it's something different, but at least the part of development of the career should be clear in a given company. And mid software developer is like something like a junior who has achieved a level of being able to work with very little help or no help, and should also know how to become a senior software developer in a given company using the technologies that are used there and the type of work. But when someone becomes a senior software developer, of course, the expectation is that a senior should know what to do and how to do, with no being instructed at every step, and should be able to mentor juniors. But there is usually not very much told about what a senior software developer can do to develop further, because it's usually junior, mid, and senior is usually focused on helping juniors, but not every company is clear about the path, what can senior do to develop further. So the question is, what's next? When you are a senior or maybe you are junior or mid and would like to know what to expect in the future. So usually the paths of career are like becoming a team leader, tech lead, manager, CTO, but those are usually positions where someone who is good at writing software suddenly stops writing software all the time and focuses on some soft skills and people management. And usually, sometimes it's common that this is like not very the very thing that someone is experienced or even wants to do in the career. So it's common sometimes, unfortunately, that someone who is very good at writing software is rewarded for that by not writing software anymore, and some people not find it very comforting. Of course, some people want to do it. So the most important question is, do you enjoy programming? So this is like some people, I know some people who are good software developers, but who are not planning to write software all their lives, and that's fine. But there are some people who actually really enjoy writing software. So this is for me the most important question to answer, to know what to do next in the career. And the post-senior programming roles, there are some, for example, someone can become an architect. There is maybe less writing of software, but more designing of the architecture of larger systems. Some companies have other levels than just senior, like staff engineer. There are engineering managers in some companies that are very technical. Some companies, for example, hire engineering managers only from people who have experience actually writing software. So the companies are managed by people who, or the teams are managed by people who actually understand how the software is written. But what to learn, actually, no one will tell you that, because at some point you are expected to be the one to just know what to do and to tell others. So at some point of the career, you are like on your own, and you are actually expected to tell other people what to do to self-develop and to learn other things, which is very unlike the path up to the senior software developer, where usually the company is giving you like the software stack and the skills needed to write the software in that company. But at some point you have to like grow over that if you want to still write software and develop your skills further. So you have to always answer the question how to specialize. Do you want to be a full stack developer, or how I like to call it, a half stack developer, focusing on backend or front end? Currently there is also like cloud computing, but there is also edge computing. There is like slightly different aspect of cloud computing, like the edge functions in some cloud providers. And there's actually, currently I tell everyone that currently being like a really full stack software developer is not really possible like it used to be some years ago, because currently knowing everything from the cloud computing platforms, all the DevOps knowledge, all of the configuration of like Kubernetes, Docker, all of the all the cloud from the bare metal to through the backend databases and to the front end. This is so much knowledge that I don't think that it is very common for anyone to like know everything, and it's very quickly changing. So I will quickly say what is like my way of doing all this, because this is something that I managed to learn from over the years. I actually started programming when I was a kid, so I had a lot of time, and it was much simpler back then. But my way is like, for example, first of all, understand the fundamentals and follow new technologies. But what I mean by that is the fundamentals. I still think, and I always thought in that way, that knowing C and assembly language is very important to actually understand how the computers work. Because we can have all our careers. I know great programmers who don't really know the very low level of programming like assembly language, but it's very useful. It's like I always say that you can be a great driver, not understanding all of the inner workings of the engine of your car or your differential or your gearbox and things like that, but it's useful to understand it because then you can have a better understanding of higher level languages. So the fundamentals that I, in my opinion, think that are important. I myself am a backend engineer, so this is my focus, of course, is low-level languages to understand how actually computers work, Unix and shell scripting to understand some concepts of programming languages and to be able to write shell scripts to integrate larger, like some systems in a larger scale, and networking protocols to understand how actually networks work to not only focus, for example, on REST, but also understand HTTP, TCP, IP, maybe not much lower level, but it's always also useful to understand even like Ethernet and lower level network protocols. And by new technologies, I mean JavaScript, which when I started to write in it, it was new technology, TypeScript, Node, Deno, Ban. But also right now, I think that a good focus of myself, and I always recommend it to watch closely, is WebAssembly, WASI, WAGI, the web standards, because this is, I think, will be important. I gave a talk here in WarsawJS a few years ago about it, and I still think that this is something. There are new companies like the WASM Cloud and new cloud providers that are focusing on WebAssembly. So I think when it is polished and more ready, then this will be important. And also newer languages like Go, Rust, Zig, Grain, Mojo, Odin, Nim. So this is what I always recommend, to know at least something about those languages and those technologies. I'm not saying that everyone should have to write good software in them, but I think that knowing those things, especially when you are a senior software developer in a company or an architect or staff developer or a CTO, then someone, for example, can tell you that, oh, maybe we will write something in Rust or Go or Zig, and you have to be able to understand if this is a good idea, how it's what are the consequences, for example, for hiring new people, because those less known languages have some consequences that not everyone will know them, so people will have to learn them, or you cannot like hire people who are already, for example, senior software developers in Mojo, which is a very fresh language, not even like publicly available right now. But I think that it's very important to be up to date with the technologies, because I myself saw so many technologies come and go in my like 20-something years when I'm doing software development, so like professionally. So everything that I see today, I know that it will like be replaced by something new. So right now, for example, Rust is very important. Even on the front end, there are frameworks that using WebAssembly you can write front end, do front end development, web development using Rust. So this is what I focus on. But of course, the other things that are, in my opinion, important is focusing on teaching others, because you can learn so much more by trying to explain the things that you know to other people. And for me, it was a lot of times when I was writing on Stack Overflow or like giving talks on, or mentoring people, I found out that I'm not fully understanding the topic that I want to explain to someone else until I try to explain it. So writing, for example, an answer on Stack Overflow, I have to know it fully. So I usually was doing some research and learning a lot in the process. Of course, writing code is important if this is something that you would like to do. So write code at work, write code at home, contribute to open source. Contribution actually to open source projects are very good way to, because everyone is welcome. Usually the projects are very, very open and you can get a lot of great feedback for your code. So it's all in the open. People are very experienced, usually very welcoming. So it's a great way to learn. And this is something that someone who, for example, is starting their career can do before even finding a job, to start doing some little contributions to open source projects. But the question is, of course, what is your way of doing it? Because this is what I'm explaining is my way. But as I said, this is something that you are not really told what to do, because you are expected to really know what to do and mentor others. So you really have to develop your way of doing things and developing. So find your own way to improve and find work that is compatible with your way. So at some point you will have to, looking for new job, look for something that is really compatible with what you are trying to achieve, in the way that you are trying to improve and self-develop. And the difference is when you are like what I'm calling the post-senior, is that like when you are junior, then junior needs to be influenced by others. So the most important thing is to find good mentor, to learn, to see how people are doing software development. But when you are post-senior, then you are expected to influence others. So you have to do your own research, find your new technologies, maybe be at your company the first person who knows some new language or some new system. You have to learn it. Sometimes you don't have people to learn from, but you need to do your own research and influence others. So this is, and in conclusion, no one will tell you what to do. You must figure it out and tell others. And actually, I would like to know if anyone has any experience in like leading some in some company or some team, development or introducing new technologies in a company. So maybe if we have some questions, so maybe even instead of asking questions, someone would like to share their own experience. So I think it would be useful, because this is what like my experience, but I would really like to hear what other people have to would like to add, maybe to the things that I was talking about, or maybe completely something different, or maybe someone doesn't agree that this is a good way to continue the career after being senior software developer. So maybe there is some time for questions, I hope.
Thank you very much for your presentation. Thank you. We thank you. So before we open the floor for people to also share their experiences, does anyone have any questions? Questions first. Here we go.
So you mentioned, for instance, I work in a company that has a very clear career path in the future. So you can go to the management track, as you mentioned, or you can go towards like staff engineer, principal, and so on. But what would you say what would be advice to people work in, so to say, much smaller companies that do not have this well-defined career path. So, for instance, you are just an engineer with no title, not senior, maybe mid, you don't know for sure. But how would you expand and move up to the company where that just does not have the titles or stuff like this?
Yeah, so this is a different situation, but in a way it's harder because you don't have like a clear path of development. But on the other hand, you are in some smaller organizations you have like more decisions that you can make. So without having like very large team of developers, you don't have to worry so much if all of them are experienced in a new technology that would like to explore. So in some ways you are restricted because you don't have like a big organization to support you. But on the other hand, you have sometimes more to tell and to decide. And you can introduce technologies. It's sometimes easier to learn smaller team a new technology that is maybe less popular. Like, for example, I don't know. Currently, Node.js is very popular on the backend, but also Clojure is a great choice. But there are less people knowing Clojure, and in a smaller team, probably it's easier to experiment and introduce it. And everyone can like join a bigger organization in a way by contributing to open source projects. And sometimes those are very good, very big, like I don't know, contributing to Linux kernel. It's like thousands of people contributing to some like Node.js. There are a lot of people, but some framework or some front-end framework. There is. Everyone can join something besides work, like some even small contributions to open source, and then have like a look on the sometimes bigger organization than any company would have. But in as you were asking, in the company environment, there are advantages and disadvantages. So, but you have like more freedom. I would say it from my experience having smaller organization. I don't know if this answers your question.
Next question.
Hi, great talk. I have a question. Have you tried Googling the word staff? And what do you think about it?
Googling the word staff? Just staff or staff engineer?
I mean, like staff in staff engineer.
Googling the word?
Yeah. Because it's, usually the attribute of a wizard, like a staff.
Okay, but do you have something like concrete that you, for example, found?
Yes, that was an opening.
That was a statement.
And, yeah. Do you think that we should recognize more levels of the developer expertise, like junior, mid, senior staff? What else? Maybe we should mimic something from the clergy, like why not arch developer? What do you think about it?
Yeah, I even once I knew a company that had like ninjas and things like that in the like official positions, official titles. So maybe something from some other industries. But usually, what's most important is it's not really a title, but what I noticed that it's not only in the industry of software development, but there is something like this when there are no more technical levels. So for just writing software, then it's usual that people are getting promotion to just because they are good at writing software. They are promoted to a position that has nothing to do with writing software. And even there is, I've heard that there is a theory that everyone is promoted until getting to a position of incompetence. So like this is like it's converging to that everyone is stopped at the position when he is the least competent, because then the person stops getting promoted. But I think that it's useful to have like more levels of technical expertise, not only in software development, because sometimes are people who just enjoy and are great at writing software. And it's unfortunate when they are promoted to a manager who has nothing to do in writing software, and they are not necessarily very good or dedicated managers, but some people are. And and some companies are like having the career paths that can be chosen between the like soft skills and people management and actually technical positions of just writing software in this case.
Sorry, I just wanted to kind of ask like a follow-up on someone's question there, because I don't think that a small company shouldn't have like a path to grow, right? So I just wanted to ask on your opinion about that, because I think that every company should have like some path to grow, and if the company that you work in doesn't have one, maybe you should look for another one. But
yeah, I understand what's your point, but the previous question was actually, as I understand it, talking about a situation where there is like, for example, a small project and 1 or 2 developers. So the career path would be like to just changing the titles of those people, but it's not like they have they are migrating in some hierarchy or something like that. So there are projects that are done by small teams, and the career path there is something different than in a large organization where you actually move in some hierarchy and you need to, for example, have a lot of juniors to mentor. And in a company when there are like 2 people, then there might be some career path or the path of development, but it's not necessarily the same because it's not like you have a lot of people that you need to take care of. So I guess that this is what the previous question was referring to. But yeah, actually, probably all organizations should have something to offer in development of your skills.
yeah, sorry, it's just because I understood company, right? And like I think because I currently work in a small company that's like very promising, and they already have this in place, so I was like very impressed.
Yeah, and also some small companies grow. So this is also something that and being one of the first developers or engineers in the small company, then you have the advantage when it is growing that you know everything from the beginning. So this is also interesting to keep an eye on.
Yes, growth and expansion creates more titles, more opportunities, and there's always a possibility for growth depending on for instance, if you're a service-oriented company and you develop a product, then you'd start to extend your range of services. Of course, you're going to grow. Here you go.
So you said that you started programming when you were a kid. I wonder whether you had specific periods in your life when you observed increased growth, when you were, I don't know, psyched about something and started learning new tech. So yeah, how was it in your case?
Yeah, in my case, I actually started, my first like very simple programs was I wrote when I was like 6 years old, and it was before internet or even BBSs or anything, so it was hard to get some knowledge. But I think that like more serious programming like in C and assembly language was started when I was like 12. But still, there was very little books, very little, no internet. When I was like, I think 13 or 14, then I had like modem to call to dial-up modem to call BBSs and find some there were very few like text files on C and assembly that I could get. And at that point, I don't really know what was like the professional software development back then, because for me it was like just a hobby. But when I started professional software development like in the late 90s, then usually everyone was full stack, and everyone was actually webmaster. It was like common name, and it was very different than today. So and it was actually possible to know pretty much the full stack of the technologies, because it was not that much. It was JavaScript on the front end, maybe jQuery, maybe Mootools, maybe something like this. And on the back end, I started in Perl. There was Python, Ruby. But it was pretty simple compared to what we have now, that when we have new framework every week almost. So and also there were not, from my experience in web development, there were not so big hierarchies of the careers. I don't know what was like writing software for banks back then. I was just doing web development, so it was like single people or few people that were like very flat structure, and everyone was pretty much full stack back then.
I think that's fascinating. Does anyone have another question? It reminds me of when I first started to understand that there is something like a community of software developers, and I asked some people that I was conversing with about why there were so many titles. Why are there so many different jobs? And I asked them to try to explain what each of those job titles was, and that was a very interesting conversation. So are you saying that you think it's a good thing to create more and more titles in the
Probably this, then it's more understandable what career path you can take. When you know which, for example, what titles are in a given company, then you know what are your options to develop your skills and to improve your own understanding of it and how your career might look like in that company, for example.
Thank you very much. Could you just step into the light, please? Our cameras are losing you, Rafał, over here. Really, thank you very much for your presentation. Anyone? Yeah, this is fantastic. Thank you, thank you, thank you. My pleasure, my pleasure. Thank you. So, in case anyone's wondering, the title I'm looking for a job as a prompt engineer. This didn't exist also, I imagine, when Rafał started. However, yeah, there are a lot of opportunities appearing, it seems, every day. We have now low-code developers and these types of people showing up. It sounds very interesting, and there's a lot of promising potential. I want to get back to our sponsors. Oh, first, I need to mention that we do have an ubikacja, is that how you call it? We do have one over here, and it's labeled currently, it's assigned to one gender or sex or the other. Today, it's universal, so anyone can use that one. We just thought you should know that, just in case. And there's also, in case that one is occupied, there's one on the other side. It's a little bit farther away, if you're interested. Speaking of our sponsors, our newest sponsor, I just wanted to mention, let me see if I can flip, I can't click these over now. One of our newest sponsors, Utility Warehouse, is a very interesting company that comes from London, or began in London, I should say. And one of the people who is with that, we welcomed as, first we want to welcome them as one of our newest sponsors. Can we give them a big hand? And I don't really want to put you on the spot, Martina. Martina Zbyszewska is here. She's one of the people who works in that company. She's not going to make a presentation today. However, we hope that you will come for our next meetup when she will make a full presentation. From what I understand, they're a small company that started organically, speaking of growing companies, and in the 1996, I was going to say 76, that shows my age. What's so funny? Okay, yeah, I was going to say 76 in 1996, and they've grown into a full service company. They're providing services for, they're working with over 14,000, I think, different distributors, and also now working with upwards of 1 million different customers, providing multi-utility service. It's kind of like if you had your electricity bill and your phone bill and your every bill all in one, and so they coordinate all these services so that you can really conveniently take care of all the utilities. I think it's fascinating, and the thing that I think they would want you to know most about that sponsor is that their main tech stack includes, I had to write this down because I found it very impressive. May I? Yes, you do. You do. You have React, you have React Native, you have Redux, TypeScript, JavaScript, GraphQL, Go, Kubernetes. Kubernetes? Is that right? Kubernetes, Terraform, AWS, and GCP. So they have a very, very broad number of different technologies that they encourage their small teams, which each work kind of like their own startups. So they're very, very independent, and they're invited or encouraged to work creatively and at their own pace. And I think it's a very interesting thing. We can't wait for the presentation. That's going to be interesting. So welcome again, Utility Warehouse. We're happy to have you. Our next talk, which I can't seem to find the slide for, is going to be, I think the title of this was, It's Going to Be Fun, I Promise. This better be good. That's all I can say. Can I welcome you to the stage because I can't find the stage, so I can't remember what your name was. Oh, Kacper Pietrzak. Okay. And the title of his talk is "It's Going to Be Fun, I Promise." We'll see. Come on, Kacper.
Okay, guys, 2 minutes of break because we need to switch the computer.
Aha, super. See you in a couple of minutes.
2 minutes, 3, maybe 5.
Yeah, I lost. There's no control with this clicker.
Difficult to explain and to say like how good the company is.
We don't have a good picture. I have no clue. It's going to do that.
Yeah, and the thing is that I really want people to come here or to fly over, but we have people in Poland but not in Warsaw.
Yes,
So that's really odd that we have I think 30 people now in Poland.
None of
And
them are in Warsaw.
no,
And why is that exactly?
I don't know. Like it's just the
Is
people
it
who
HR
are.
or is it what?
I'm the recruiter.
So you are the recruiter, so you should know then why
I don't know. Like the thing is that
it's difficult to find.
I think that the main thing is that we were looking for backend developers mostly last year. For Golang developers, and Golang is not really in Poland still. So that was the main reason, and another reason was that we, well, I think that. Rafał mentioned
You
that.
can read.
All right, folks, we're back with Kacper Pietrzak, and the title of your talk, Kacper, is
It will be fun, promise. Oh, the slides are here. I'm not sure yet whether I'm going to sit or stand, so let me be not decided. So while the talk of Rafa wasn't technical at all, mine will be all code, so be focused. A lot of code here. So yeah, I decided to show you how to implement your own promise library. For me, it's just pleasure of doing something from scratch. But if you're not motivated enough for this reason, I know of some employers who use this kind of challenge for an interview task, so you might want to hear. So yeah, I'll try with this one. Never used it before. So yeah, I just prepared a set of examples that document the behavior of the promise object, and we'll be going one by one and just implementing them. Yeah, this is the basic usage of the promise object. We just resolve a promise after 1 second with the value hello, and then define the callback using then method. So basically, it should just print hello after 1 second. So the implementation of that, once we define the boilerplate, First, we define the resolver parameter. So at first, it's a bit tricky to get because this part here, the resolver, it's the whole function here. And then we pass a resolve function to it that will get the resolved value. So in exchange, we get the value. So with that value, we need to call the then method, or actually the callback pass to the then method. So first, we need to save it when someone passes it to us. And then when someone calls the resolve function, we can finally call the onResolve with value. So it's fairly straightforward. And I'm really proud that I coded a little Vue component using ChatGPT because I do not know Vue for running code on the slides. So yeah, it actually works. In all of the slides, we will see the little flag showing up. It says that the execution started, so you could see the delay here. Yeah, so now we have a really similar example, with the exception that now we resolve the value immediately. So actually, with our code, nothing will happen when you run it. And it's because at the time of running the resolve function, we didn't have onResolve defined. So basically, nothing will happen. So to fix that, when someone resolves value, we need to save it for later when we have the callbacks available. So let's do just that. Here I just extract the resolve function to the method. I called it propagate value because it makes more sense to me than resolve. Yeah, here we just save the value. And we not only want to save the value, but we want to save the fact of resolving. So basically, if someone resolves value that is undefined, we have no way of telling whether it actually resolved or not. So that's why it's useful to have another property that says resolved. And then in our then method, if someone calls the then method, and we already have the resolved value, we can just call the onResolved right away. So this should actually make this example work. And it works. So here's a little twist. It's about the order of things. If we print something right after our then, it's in our implementation, it nicely prints hello world. But it turns out that if we go to the native promise object, the order is reversed. It's word hello. So this isn't something that we need to think about in most of the times, but it turns out that the resolver function is called synchronously in the same event loop iteration, but what we pass to the then method is called in the next event loop iteration. So basically we need to mimic that somehow. We won't be able to do that perfectly. This is like microtask, macrotask queue differences, but here, for the purpose of this presentation, we can just basically fix it by running this part in set timeout 0, which will just put it to the execution of the next event loop. And yeah, and here's the example that looks a bit more what we are used to. So let's see how to implement that. So yeah, for now it's unchanged. It's all that we added before. And here it's basically when we work with promises, we see that it's almost like the then method makes another promise. So we are doing just that. In the then method, we'll just instantiate a new promise. And then instead of storing onResolve on ourselves, we will store it on our child. So this nicely gives us this opportunity to have more children in the future. Basically, we no longer have the onResolved on this object. We have it on this.child, so we need to also execute it there. And let's see how it works now. it just prints hello. So we are halfway there. We didn't break anything, but it's still not the example that we want to see. So we nicely created this chain of promises by the child property. But we need to actually make this value flow through this chain. So here's a little animation that I made. It's very professional. So yeah, basically, each time the onResolve executes, we need to get the last value from the onResolve callback and pass it to the child. I always finish before this animation. It's too slow. Yeah, so basically, we need to call the propagate value on the child here. So basically, we just say, okay, go propagate it to your children, or yeah. So with this additional line, the code works like the following. Basically, it prints hello twice. So we executed the chain, but the value doesn't change. So how do we get the actual value from the another onResolve? It's basically just returned by this onResolve callback. So if we get it here and pass it to the child, we get a hello bye. So yeah, now with, there's about 15 lines of code, and it already does something quite complex. So yeah, this is actually a break time for me to have some water. And also, oh, thank you. Also, this is the first time I used slide dev for making my slides, and I was so impressed. It was so easy to use for developers. I'm not affiliated with them in any way, but both of these tools are open source, and the one thing that I really liked in slide dev that you can actually make or embed your own view components. So yeah, if you're a developer, you can really go crazy with your slides. And Excalidraw, I use it all the time at work to make really nice, architecture diagrams or something like that. Please use those tools, or I don't know, contribute. They're amazing. Thank you, guys.
Wow.
Yeah, so we are almost there. Here's the part that makes the promises feels like magic. So before, basically, when we had a lot of asynchronous code and we just defined callbacks and callbacks, we would end up in a place called a callback hell, which would be basically this really awful level of nesting. And one feature that promises have is the flattening of the chain of promises. So basically, if we want to do two async operations in sequence, we can just define the chain of these operations instead of doing further nesting. So basically, this console log at the bottom should execute with the value by after another 1 second. So let's see how it works currently. It just prints hello promise because we just, print whatever comes from the previous onResolve. So basically here, if the next value is a promise, we want to do something else. And it turns out it's quite simple. We just need to wait for the value from this promise, and then we propagate the value to the child. So it can be shortened to this. Sorry. Oh, so let's run it. Hello and bye. So yeah, another feature of promises is that it's not only a single callback. We can actually pass an object that represents the operation that can be finished or might not be finished. So basically, at any point in time, we can just access the value by calling then. So in this case, we have two separate chains of operations, one here and one at the bottom. So it should basically print hello after 1 second, then bye after 1 second, but here we we print hello basically at the same time that this hello should be printed. So in reality, this should be hello twice, and then bye after a second. So if we run it now, it just prints hello, so it's obviously wrong. And it's because we have a single child property here. And we just overwrite it when we define another chain. So basically, this is the moment when we can finally have more children. Instead of storing a single child, we can just have an array of children and do all of this propagation and child processing for each one. So this is it really. If we run it now, we get hello, hello, and bye. So both of these chains run. And there's one twist here. What happens if we have these two chains in different points of times? So let's see how it should work in the native implementation. So basically, it should just print hello after this 3 seconds, because when we come to this point, the P promise is already resolved. So if you want to implement it, or actually, I didn't show you how it works with our implementation. So our implementation is actually rerunning the children again. So here's the final change, which is basically just removing the children when we already processed them. It's kind of a rule that the single callback for a promise runs once. So if we just process that, we can just forget about them. And it works. So yeah, basically in 30 lines of code, we have a really powerful idea that makes JavaScript a really pleasurable language. Obviously, it's not complete. It doesn't have like, I don't know, catch method or something like that, but the core idea is there. So yeah, I think it was really easy to implement by having these examples. And this is something I really try to do at work too. Like first start with definition of the problem and different use cases, and then the implementation, the code is usually much more obvious to write. And this was all I prepared for you today. Thanks.
Thank you very much, Kacper. Any questions about this promise, this very promising promise? It looks kind of complicated to me, but everything looks complicated to me. Any questions? Here we go. Oh, I heard that nearby. You promised it's going to be just a question. Yes, yeah? Okay.
Where can I find these slides? Because I kind of want to do something similar to
the slides. Yeah, so actually they're local on my computer. There's not even a repo, yet. So let's be careful with this computer. And if it doesn't, burn down or something, I can just deploy it, because it's just a website. So I can deploy it using GitHub Pages or something. And I'll make sure to post a link on Facebook, on WarsawJS or something. Yeah.
Yeah, thanks. First of all, maybe that's going to be a silly question, because I'm just a wannabe developer right now with exactly 0 days of commercial experience. So I mostly understand what you did there, but I never seen console log without any parameters right there.
Oh, sure.
What I've seen there, this is the first time, I haven't even written that, because I haven't written a lot of stuff by myself, but this is the first time that I've seen a console log without any parameters, and it done something, and I don't really understand why it console logged exactly those results, that response that been there. Could you explain that?
Sure. So basically, it starts with the first example. So probably I didn't have to use it, but it's just a shorter way of logging something in this way. So it all comes from the fact that in JavaScript, there's this concept of functions as first-class citizens. So basically, function is just a value that you can pass. So there's really no difference. Or actually, if we have 5 more minutes, I can just show you.
5 minutes?
Yeah, maybe not 5, maybe 30 seconds is enough. Oh, I will be coding with one hand. This will be fun. So basically, if we have a promise, like this one, oh my god. Sorry, oh, bigger, yeah. Guys, I don't think it's going to work. I'm doing hardcore stretching of my fingers here. Oh, thank you. What a wonderful human being. So yeah, if we have a promise here that we just resolve right away. Even bigger, right? Probably. Okay. Yeah. Let's go crazy. Okay. So if I do something like this, console log the value. Maybe I even want to console log an object with a property value so we know it comes from here. It will say that, right? Then a similar thing I could do is to just print the value, right? It will print hello. But then basically if all I do is execute this function with the same parameters I get, so basically here, this whole arrow function is a new function, right? And all I do is just pass these parameters to the console log. I might as well use console log instead of this newly created arrow function, right? So basically this all shortens to this one. Cool.
A lot of fun.
I'm glad.
I remember that we have multiple children for our promise. Why do we need
wait, I need to locate the person that's speaking. I feel weird without that. Oh, thank you. Now I can listen to you.
So why do we need multiple then for one promise? Why can't we have just one child in general? So why do we have to implement children? And it's still strange because I haven't seen that people ever use like 2 then for one promise. Mostly we have just one promise and we have 1 then per one promise.
So I'd say this is a convenience that if you are used to very simple asynchronous flows, you usually do only one thing when something asynchronous happens. But in more event-driven systems, stuff like that, you have a lot of async operations and a lot of things that depend on these async operations. So actually having this abstraction of an object that is an async operation and not a single point in code, a function that will execute when this operation finishes, you just get much more flexibility from that. And sorry? Yeah. Nice.
Thanks. Okay, so I think I've got a good example of when multiple thens come in really handy. So first of all, there's something called cache stampede. It's when you're using caching, so basically remembering the values of past calculations of I don't know, some HTTP requests or some such. So a cache stampede happens when your cache is cold. So when your cache is empty, when you've just started an application. So what usually happens when your caching implementation is naive, you usually have a map, a container for those pre-computed values that you've done before. But what usually happens at the start is like you get 100 or 1,000 requests for the same thing. So you start computing them all in parallel. And if you do a naive implementation of caching, so basically you do key value, then it's not going to solve your cache stampede problem because you're still going to have parallel computations. Like the value is still not there, so you're still firing up new threads of computation for the same thing. Whereas if you're using a map where you assign a promise to each sought value that you would need, it solves your cache stampede problem instantly, because then you're registering you're not checking for the presence of a value that's computed, you're checking for the presence of a promise. So am I computing or have I computed this value? But this little trick allows you to decrease the load on your backend services, on stuff that actually computes stuff for you, sometimes by 1,000-fold. So this is one situation where the memoization, the remembrance of promises versus the final values that they convey is super helpful. Like, I use this all the time because I deal with a lot of backend stuff. So yeah, if you're gonna stay for networking, then we can discuss this later, because I'm gonna be here for a while, I think. So yeah, thanks.
Thanks. So yeah, this is my final question. I mean, final question that's coming from me. It's a small one. What is your honest opinion for when you're tasked to write your own promise implementation during the job interview?
So I'm the worst, actually, because in my company, I'm known for doing hardcore JavaScript questions. I think in some situations this is justified. If you work with code bases with really convoluted JavaScript, you want someone who thinks in JavaScript, and when they need to do something like, they're like, oh, fun, let's do it, But in many positions, when you're building a web application that maybe doesn't have so many legacy areas, then maybe, I don't know, maybe not going beyond that surface is enough. I'd say it also shows if someone is like, really, I don't know, passionate about it, because usually you don't need it, right? So if you just think about, am I able to do it, and you do it, then it just shows that this person might be the guy you're looking for. But I'd say for most of the positions, no, it's not necessary.
Wow. Okay.
Can I just get one last question?
Sure.
It's a very important person.
There's a very important person in here?
There.
Oh, of course. Yes, of course.
Sure. It's a nice story.
I need to tell it because 8 years ago there were two very small guys at our WarsawJS meetup. It was 8 years ago, and these two guys said that they have something that makes fantastic with Arduino, right? And this guy, he was 17, and he showed in front of the whole community that he really figured it out. And it was so amazing. We were, oh my God, what this guy is going to do in 8 years, and now we can see it. So, and they had this performance together with Bartek. So Bartek, you're absolutely entitled to have this question.
Yes, okay, so it's more of a statement than a question. I know you like them. But I think what Kacper wanted to say to you about the last question is more or less what Rafał was also trying to say about knowing your fundamentals. So if you do that, I think how promises work. Kacper, in this presentation, showed you a lot of different edge cases that you have. And I think that's a really valuable thing to do, even if those are interview questions, to learn those things, and you get the gist of fundamentals and what happens underneath, more or less. If you can implement it yourself, I think you understand it better. And I think that's why it's super valuable to do those things. And the second thing, it's not a question, but follow up to what Piotr said, is that we've been coming here for a long time, and you may have noticed on Facebook message about Kacper's presentation that it said that Kacper is a junior developer that has been working with, I don't remember what exactly, but I think that was one of the first bios that you've created, and that was from 8 years ago. And that's why it still said junior developer after 8 years. So yeah.
Wow, junior developer, this is a very big child, yes? Speaking of children. Very big child. It's really nice to hear that you guys have been coming here for so long. I think that's very encouraging. For me, it means that maybe we have some kind of a longer future. Kacper, it really was fun. It really was fun. We thank you very much for your presentation. Give Kacper a hand. You kept your promise. Can I ask a question? You prepared those slides yourself?
Yes, I did.
You see, sir, this guy spent the time. He put in the energy and the time to actually create these slides. And this is what I love about coming here. Some people are very creative and very resourceful. And to expect that you might find these somewhere and be able to use them, I guess you guys could strike up a deal, I imagine. However, I really thank you. And to my friend in the back there, this is why we have lightning talks. Yeah, if you have a topic that you'd like to explain or an approach to software development that has worked for you that you'd like to share with our group, we very much encourage you during the lightning talk segment to come up and give a presentation. You can win a free 100% JetBrains license, and we're looking forward to that. Our next speaker in just a moment is going to be Sasha. Sasha, are you still in the room? Oh, great, we haven't put you to sleep yet. And hold on a second, because I have the title of your presentation right here. The title of your presentation is going to be, drum roll, brrr. The title of your presentation is going to be, oh no, it's not that one, it's this one. Distributed Systems for Front-End Engineers. So everyone, in just a moment, I guess you have 1 minute to stretch your legs. Yeah, are we ready? Okay, you have 1 minute to stretch your legs or do that other thing in the back, if you like. And we're going to ask you to give a big, warm welcome to Sasha. Yeah, you can start now. Yeah, give it to him. And Daniel, thank you so much for coming in with the other hand. That was way, and you ran all the way from the back. We really appreciate you guys pitching in, cooperating. This is a community after all. This is what we mean by community. If you see a second or something you can pitch in, please, by all means, participate. We love that. It's true. You ready? All right. Oh, there it is. Distributed Systems. Okay, once more. Sasha, go ahead. Welcome.
Hello. So I was thinking how to start this presentation, but my eyes got sort of not wet. I forgot my eye drops. Did you know that actually eyes is the only part of the body that gets oxygen through air and not like blood system? Anyway, we're going to talk about distributed systems for front-end engineers. I think that understanding backend and understanding distributed systems will make you better front-end engineers. So who am I? My name is Sasha. I work on distributed systems at Box. My team in particular does distributed messaging. We are providing best-in-class point-to-point delivery systems, scheduled and repeated jobs, and we also allow our engineers to effortlessly benefit from publish-subscribe communication. So actually, I used to be a front-end engineer. That's why I came here to share with you and try to convince you to move to the dark side, simply because it's much cooler, it's also less stressful, and you can sort of enjoy it more. Now, our journey today will begin with an exploration of what actually happens once you click a button to stuff appearing on your screen. We will take a social network as an example, and we will learn all the concepts taken into account this example. So we will scale it from absolutely nothing to a large distributed system. We will select a data storage for it. We will learn about communication patterns and technique, and we will ensure that our system is reliable. Now, what actually happens? So we click a button, voila, your backend returns JSON, like you're happy. You call some Axios on the front-end side, underneath is an HTTP request. You don't really care what's going on, right? Well, wrong. So to make sure that we have the same foundation, HTTP is a client-server protocol that makes sure that our messages get delivered and that we get a response. This will be important later on when we discuss protocols for the backend. Well, underneath, it's not as simple when you click a button. This is not a real system, by the way, so don't copy it, don't repeat it at home, really. I drew it in like 5 minutes. So once your request reaches the so-called backend, it goes to an authorization service, then it goes to a microservice that may be calling 5 other services. It may have cache, it may have their own database, may produce 5 different events. It is also auto-scalable, rate limited, and so on. So this escalated sort of quickly. As you see, we cannot really understand what's going on. Let's start from the beginning. A distributed system can be defined as a set of computers connected through a network that work as a single computer. So let's talk about this in the context of a social network. Let's say we build our new Facebook, whatever. We push our code on our local computer. We connect it to some MySQL. We map our local home IP address to some GoDaddy domain name, and it's done, actually, it works. Now, we have no users, so one computer is actually not a problem. That's what I would do, actually. As we get more users, we would need more computers. Now, here's where the problem starts. Once we have 1 or more computers, you need a load balancer to distribute the traffic between those. So we will have a load balancer that directs the traffic either to one instance or to another. And we'll also extract our MySQL to a separate computer to make sure the data is consistent. As we scale further, we have more users, more traffic. There is actually very little difference between 2 computers and n computers. So we may just add more computers, and that would be it. Most of the companies can and should stop here, simply because they don't need further expansion into the field of microservices. Companies like Box need to scale further, simply because our system is so big and so complex. The amount of users simply, well, it's kind of hard to handle when you have a monolith. So once you have a monolith and your company is big enough, you have suddenly authorization teams breaking photo storage, you have problems like infrastructure, trying to max out your database's performance. It gets difficult pretty quickly, and I worked at such company. Now, that's why we are moving to microservices. So what do? We move functional specific components to a separate executable node. And yeah, that's it. The term micro doesn't necessarily mean small, it means smaller. This is very important since a lot of people think that, okay, microservice is like, that's only one thing. No, it can do a lot of stuff. We also extract our database. Oh, sorry. Yeah, each microservice will have their own database simply because this allows us to avoid a mess. If you have 2 microservices accessing the same database, then you won't know where is the change happening, and also you will have race condition and other kinds of problems. Doesn't make it clear so far? Is it good? Good? Do you understand what we do on the backend? Good. However, it comes with a lot of problems. Once we extract it, once we have each database for each service, how do we synchronize data between the microservices, right? It's kind of a mess. And if you do synchronize them, then there is also latency between the computers. So what do? That's where CAP theorem comes in. So developed by Eric Buer many years ago, it says that we cannot provide 100% guarantees for the following constraints. We have consistency, partition tolerance, and availability. So a little bit about that. Consistency is when on every read operation, we return the newest data. Availability is when we return non-error response without a delay on every request. And partition tolerance is when our system is available, even if some nodes are down. This still is a bit complicated. Actually, I didn't get it for the first time and second. So there is an updated version of CAP, which is much simpler. We either sacrifice consistency or latency. Now, what happened with partition tolerance? It's pretty simple. In modern world, the system is either partition tolerant or not. So we don't care about that. Most distributed systems are partition tolerant, and if your system is not, then you should hire better engineers. Now, taking into account CAP, we should think, how do we select our data storage? We have mainly two types on the backend, SQL and NoSQL. Well, each comes with each pros and cons. SQL is good when you have relationships. So whenever you have some sort of relationships, it's good to choose. However, it has high consistency, but really bad at latency. It's really, oh my God, sorry, I forgot my words. Anyway, so whenever you try to scale out SQL, there's a problem starts. However, sorry, I'm so sorry. Give me a second. Thanks. So when it comes to NoSQL, we don't have any structure most of the time. We have high scalability simply because such database was designed for high load. However, it comes for a specific use case. For example, we have NoSQL databases for key value, for JSON objects, geographical locations, we have time series, and all kinds of stuff. They were created for a single purpose of handling an enormous load for a specific use case. Oh, they also don't guarantee consistency. Yeah. Now, it doesn't matter whether, oh, sorry, what is going on? So we have two ways of communicating between microservices. Since we now know the data storages, we store the data. However, they need to talk to each other. We have two ways, synchronous or asynchronous. So asynchronous communication is the one that you are familiar with. This is HTTP and TCP. You send a request, you wait for the response, you get your response. It causes blocking behavior. However, the big pros of it is that both client and server are synchronized. Asynchronous is when you kind of like in the real world example, you will send a postcard to your friend in Japan and it just works. Well, your friend will pick it up from the postal office when he is available. So we don't have any blocking behavior. This allows us to have higher performance. However, it comes with the sacrifice of requiring more logic to handle errors and responses. Now, it doesn't matter whether we use synchronous or asynchronous communication, we need to transfer data somehow, we need some data standard, right? So here we have a simple example of a JSON, just 3 fields, name, age, and email, and we're gonna try to transfer it on the backend. We have many protocols on the backend. The ones that you're familiar with are JSONs over HTTP. You may know JSON over TCP. However, they're not really optimal for the backend simply because we don't need a lot of stuff. So JSON in UTF-8 payload cost us 64 bytes, while Avro and Protobuf comes in 50 and 30. And as you see, most of the stuff is taken by HTTP headers, which we really don't need. So we can just throw it away. So you say, okay, 300 bytes versus 70, not that big of a difference, right? Oh, wrong. It's just 3 simple fields. And imagine we have 1 million such messages per second, which is not a lot. This will come at a cost of 26 terabytes versus just 6 in a year. And this is just a small piece of data, unrealistic example. In the real world, we have much bigger ones. So we need to think about that on the backend too. Now, ensuring systems reliability is quite important. Because we're a social network, we basically earn money on ads. Every second we're down, we can lose millions of dollars. So that's pretty bad. So how do we make sure it doesn't happen? Well, we have redundancies. So we have more than we need to. We have more instances of execution nodes, more database instances, and so on. This will allow us to redirect traffic to healthy instances. Load balancers play a crucial role for it, simply because they handle failovers and make sure that the traffic goes to healthy instances only. Now, monitoring and observability, probably one of my favorite topics. I cannot stress this enough on how important it is, especially coming from the front-end side, because you basically see your outcome, whether it works or not. Well, on the backend, you don't. So we collect metrics, logs, traces, everything we can. So in case we have a problem, we look at our observability instead of guessing. On the backend, we are simply blind if we don't have it. Now, we may have redundancies and proper observability. However, we will still fail from time to time. That's why people like me are still employed. So, yeah, what? Yeah, thanks. So we can we can implement different resilience patterns such as retries or cascading failures prevention or timeouts. All of that will help us. However, also a big one would be diversifying through geography. For example, we started with, as you remember, just one computer. Well, what if it burns down? Well, we can have 2 computers. What if our apartments burns down where those computers are? We can have multiple apartments. We can have multiple cities if a hurricane comes in. We can spread out through different regions, countries, and even continents. It's just a question of how far do we want to go. And I came a little bit faster than I was supposed to, since I usually talk fast. So as a conclusion, we sort of now, I hope, understand better what we as backend engineers do and what distributed systems people do. We know how to scale application from 0 to n, and we know that microservices is not just a flashy term, but rather a necessity for a lot of companies. We know how CAP theorem applies to real-world choices, and we know the difference between SQL and MySQL databases for specific use cases, difference between synchronous and asynchronous communication protocols and how they affect our performance and bandwidth. And we, of course, understand the redundancy and monitoring. And thank you for your attention. If you have any question, I will be happy to answer them.
Thank you very much. Thank you very much. Any questions for Sasha? Oh, where's Mehdi? I'll be right there. 1 second. Toś tam Wojnarowski słyszałem. Momencik.
Hi, I got a question, like regarding, you showed on one of the pictures that you split your database from one instance to several instances. Oh, very in the beginning. Okay, what strategies do you use in like splitting the database?
Oh, no.
Let's say 2 microservices use the user entity.
Yeah, so in the real world, how it happens is that you have a second, you basically copy your database, and there is a whole algorithm on how you do it. You replicate your database as in the, well, databases allow you to save the log on all of the changes. So what you do is you take that log and you replicate the exact state of the database. Then you write to both databases, you fill the gap, you also fill the gap after that, and then you cut off the old one. Does it make sense? Like there is basically on the internet a whole algorithm for that.
It sounds like you need a diagram for that. Wow.
Yeah, this is true.
Any other questions? For Sasha, distributed systems. Oh, of course, back there. Mehdi, you see? Yeah. 1 second, Sasha.
So you mentioned that headers for JSON, sorry, Sasha, headers can be redundant information. So what if in the JSON we also have long field names? Is there a common practice for backend communication to like name fields A, B, C and just decode them on the other side to save the payload size?
So that's what Avro and Protobuf does actually. Yeah, simple as that. They've saved a lot of space. We also have. Are you okay? We also have a concept of
bravo!
So on the backend, we also have a concept of headers if we need it. And what we do is that Avro and Protobuf does exactly what you said. They can sort of just have fields number 1, number 2, number 3. That saves a lot of space for us.
All right, thank you.
Very immediate answers. It seems like you're prepared for any eventuality. I like this idea of redundancy. For me, that was the resounding message that stuck with me. Anyone else? Question?
Yeah.
For Sasha? Where?
So when should we scale database horizontally? I see that your feed...
Okay, I see.
I see that your feed service, microservice, have just one database. When should we have multiple instances for, if you have like multiple feed services, probably database will be bottleneck. So when should we scale database?
Okay, I don't understand the question, sorry.
I mean, okay, imagine you have multiple feed services, like tons of them, and you can't have one instance of database.
Yep.
You may need to have like multiple instances of the same database.
Yep.
When and how should we scale it?
The database?
Yeah.
Well, whenever you need to. So it depends on your tech stack. If you're using something like GCP or AWS, then it will scale out for you.
Vertically or horizontally?
I think it depends on the type of database you use.
I think if you have like, it's not easy to synchronize even databases.
Yeah, it's not. Yeah, I'm not saying it is. So that's why I said that SQL databases are really bad. Did I say it? At scaling out. At max, you can have something called master-slave architecture or main and follower. And what else? There's also a few tricks, but that's all you can do, really.
Main and follower, I like that.
Yeah.
I think we discussed this language of master and slave earlier at another meeting.
Yeah, sorry.
It's quite all right.
Okay. Sorry, why NoSQL databases are so good at scaling out?
Well, they were designed for that. Like companies
every?
like Facebook actually came up into one room and said that, okay, we need some databases that need to handle our use cases because we have a lot of traffic. So the database like Cassandra was designed like that to handle enormous load. But architecture of Cassandra is really complex, so it needs a whole presentation on its own and probably a few scientific papers.
But okay, we still have MongoDB. It's still NoSQL database, and that, I don't think that it is such good at scaling out.
Sorry, again?
Is MongoDB good at scaling out? It's still NoSQL database, but I think that...
I never used it in production, so I don't know.
Hi. So have you heard about this anti-pattern called distributed monolith?
Of course.
Can you tell me something about it, like how to avoid it or what
Yeah,
leads to it? Thanks.
So, from my perspective, we should hire good engineers at first. No, really, like, I've seen a lot of mistakes done simply because of over-engineering or people not really understanding what they're doing. So that would be the first thing that comes to my mind. I would say that one team should own a particular microservice. You don't spread out it through different teams, and a microservice should serve only its purpose. For example, authorization does authorization, emailing service does emailing, and nothing else. And yeah, this is pretty much it.
Yeah. How to avoid this monolith situation. It sounds like very wise advice. It sounds like, have you ever faced that situation yourself personally?
Distributed monolith?
Yeah.
No, but I got lucky with getting into good companies.
I guess I think the advice of hiring good engineers was great. Listen, folks, that's the end of Sasha's presentation. Please give him a really, really big round of applause.
Sure.
We're going to immediately, I think, take a break to eat some pizza. And after that, we have at least one lightning talk. So please, let's take 30 minutes, okay? And meet back here in about 30 minutes. Thank you, folks. 25. Let's make it 25. Thank you so much. Okay, 5 minutes. We're starting, folks. In 5 minutes, we're going to have a lightning talk. And also, I forgot to ask, is anybody here for the first time? You're here the very first time? Welcome. I meant to do that at the beginning. Welcome to everyone who's here for the first time. We hope to see you again. Very nice. Less than 5 minutes, in fact. Nice. Oh, I know. A little reminder over here. Okay, well, it's really nice to welcome you for the first time. I'm ready. Okay, where is he? Where'd he go? You? All right. All right, everybody, we're back. The first thing I think we need to do, everyone, if we can get your attention for a moment. Hello, everyone there? Okay. So the first thing I think we need to do is to thank our sponsors again, please, everybody. Please give a big hand to Fresha, Pack Help, XFang, and Utility Warehouse. No, that will not do. Let's try that again. Everybody, let's give a big hand to our sponsors. Come on, these people keep the lights on, okay? And of course, XFang is a wonderful partner. I'm just saying that because I'm wearing the XFang sweatshirt. So we have one more thing to take care of, and that is the lightning talk that was promised. Appreciate you for participating online. Machniewski, we love you. Yes, absolutely. And also, yeah, so please add your comments. Visit us also on Facebook, if you could, and like, share, and subscribe, as they say. All right, are you ready? Robert Kawecki, tak? Interesting, very. Interesting that I remember this. I mean, listen, these names, you know, they may be simple or sound simple to you. For me, like, my tongue is like hurting. I feel like I have to go home and soak my tongue sometimes after trying to pronounce some of these names. We're still syncing. We're in sync? Ready to go? Yeah. Once more, Robert Kawecki, everybody.
All right, yeah, thanks for the warm welcome. And I mentioned something about the cache stampede, however scary that might sound. And I'd like to show you something about, basically, about the issue. Is this? Yeah, let's just make sure that we can see it properly. It's okay. It's not working as I'd like it to, but it's kind of working. Okay, seeing anything? It's big enough on my screen. Seriously, I have no idea what's going on today with the resolution, but anyhow, let's just have it. Okay. So, here's an example server that uses the Fastify web framework. And basically what it does is it computes some results. The thing is, when you ask it for a result, which is basically a word that's reversed, basically its letters all jumbled up, it's going to do two things in sequence. First, wait to simulate some computation that's fairly, well, expensive. So basically wait the number of seconds that the word has, like the same number that the letters it has. Then you increment the dollars that you spend to simulate the cost of this computation. So you see, it takes so many seconds, so it must be heavy and must cost your company money, right? And then basically generate the result, yeah? So what we're going to do here is demonstrate the two approaches that you can take when it comes to caching, and see how this little trick with promises can help you optimize your app. whatever it is you're doing with these heavy computations. So first of all, obviously we need a cache, which is a map. I'm using the ECMAScript 6 map objects, just not to, because it's less yucky than the opening bracket, closing bracket, yeah? So in this map, we're going to hold our cache. So basically, I'm defining a route that will allow me to request the result for a given word, and basically it's the word in reverse, obviously. But what I'm doing here is, if the cache already has the word, so if I've already done the heavy computation, I'm just gonna fetch it and not incur the processing cost. However, at the beginning, obviously, there's not going to be the result waiting for me, so I need to compute it with the handy await here, then save it in the cache for the next person to find it, and return the result. So far, so good, yeah? Also, I've prepared a helper endpoint to let me establish what the cost is so far. So let's go to our trusted browser. Can you see this? It says spend $0. Maybe I'll enlarge it just to, it's a really big zero, yeah? So just refresh it just to make sure. Yeah, so right now we're at the starting state. And what I'm going to do now is request some results from the server. So where's my console? Okay, so here's the console, and here's I'm just gonna need one, I think. Okay, so here's a console that uses Carol, you probably know this tool, to request the reverse of the word idempotence. It's not a medical condition before you ask, but it's a hard word. It should take a few seconds to process it, yeah? So let's just launch it and see what happens. Right now, without the ampersand and without the typo 2. Okay, so as you can see, you actually have to wait some seconds because of how we've coded it. And yeah, we're gonna get the result real soon, I promise. Okay, so apparently the reverse of this word is whatever. Well, we've seen that you had to wait a fair bit, yeah, for the result. But now let's see if our caching actually works. Yeah, okay, yeah, it does. But the thing is, we've only spent a single $1, yeah? So that's great. However, what would happen if we were to query the API in a way that's parallel? Like, let's ask it about idempotence 2. It's a harder word, yeah, so 12 seconds, I think. And just spawn a few processes that are going to, do it in parallel. Like, yeah, 6 instances. So by this count, our caching, it should cost us $6, yeah? Okay, yeah, our results are starting to pour in, as you can see, into the console. I think they're done. And the budget is now, it's a bit stretched, yeah. It even went to 8, yeah? Maybe I just miscounted the clicks. Anyhow, yeah, we're losing money. Okay, so now how do we actually optimize this thing? So this is going to be a tricky one for me because on my screen this window doesn't look so nice, but let's have it. Okay, so instead of caching the results, we're going to cache promises for results. So instead of doing this, we're going to do something a little different. So instead of await here and setting this, we're going to do this instead. Like I actually have to be looking at the projector, sorry. Okay, so I'm taking the promise that's, yeah. I'm taking the promise that's being returned from here, saving it in the cache, and now I can return the cache get, and I'm gonna take the word, the key corresponding to the word that I just did. Where to, yeah. Thank you, editor. Okay, so it's a small change, yeah? But let's see how it behaves now. Let's see if I got this correct. So if my cache has the word to process in it, I'm gonna return the promise, and else I'm going to immediately populate the cache with the promise that's going to have its next dance registered, and I immediately return the promise, and it's okay because the function is async anyway, so I can return promises from async functions, obviously. So let's see how that works now. I need to restart the server, of course. I can't either see the terminal. Okay, yeah, there it is. So let's see if it's any better now. Oh, but the conclusion. Okay. Okay, we're at 0. Firing up. Just to clear this a bit. Yeah. And now we gotta, like, I think it's 4 of them. So let's wait for results first. There you go. Okay, yeah, the results look fine, just as fine as they did before. And our budget is now, it's now in a much better shape. So using this simple trick, by reusing the same promise and by eagerly saving it in the cache, you are able to actually save virtual dollars, as we've demonstrated. So thanks. This is a simple technique, and I hope it really adds to your toolbox. Thanks, guys.
Okay, Robert, that was only 7.5 minutes. Not bad. My question for the organizers is, do we still give away the prize if it takes more than 5 minutes? Of course we do. That's a silly question, of course. You take an extra minute, that doesn't deprive you of the prize. I've been told, are there any questions here for our friend before we move on to the next lightning talk? Any questions? Anyone? This light is blinding. Thank you very much. Thank you very much, lightning talk. Well done. Michał Matwok? Michał Matwok? Is that you? I've been asked to invite you here to the stage for some reason. Listen, folks, don't forget that our next meetup is on the 14th of June. I'm going to be saying goodnight now, and just look forward to seeing you next month on the 14th. I understand that possibly tickets are already available. Is that true? Tickets are already available, so we really hope to see you next month. And also, I forgot to welcome our newcomers. I saw that there were 2 people here for the first time. So let's give a big welcome to the newcomers to the community. Give it to them, yeah. Michał Matwok, where are you? Matwoka? Oh, przepraszam. Najmocniej. Bardzo mi miło. Here you are, sir. Welcome, Michał, to the stage. Welcome.
Pokażesz slajdy?
Mam jakiś przycisk? Okay, hello. I'm Michał Matwoka, a full stack engineer at Pietrzak. But this is just my small lightning talk today. So I thought it'd be fun and informative to maybe give you a very quick briefing to the exact 4 new features coming to the JavaScript language this year. So maybe a quick intro to how features, well, to what the release process is for JavaScript, the language. So we have many JavaScript implementations. You know, Node, Chrome, Dino, Firefox all have their implementations, but there is a single standard behind it, and that's called ECMAScript. So ECMAScript is the single blueprint for how JavaScript works and the way that new features get added. And so for the, well, in the early days of ECMAScript and JavaScript, it's been pretty chaotic, as you can see. But since 2015, the schedule that ECMA, the organization running the whole process, has been coordinating, has been really predictable. And that's every single year. In June, we all get a new version of the whole language. So, well, June is right around the corner. So next month, we're going to get ECMAScript 2023, the 14th edition, and it has exactly 4 new proposals that got accepted and are shipping in basically all environments that you can use right now anywhere with regard to JavaScript. So let's see. Change number 1, you can now change array by copy. So we've got a whole new 4 methods on the array prototype, where you could actually see in the previous talk, we had to use the spread operator on an array, and then do dot reverse to get the reverse version. Now you can just do to reversed every place that you would actually want to do that. So you get a very efficient way of getting a reversed copy of the array without modifying the original one. And this applies to reversed, sort, spliced. And the cool thing is, you can also do that even with bracket notation. So that's a new thing. Array find from last is kind of on this theme. So that's very similar. Again, not a revolution at all. It's just that whereas previously you could do dot find, you can now do dot find last, and it will give you the result from the very end. A bit of a niche one, but we're not skipping over any new feature this year, is you can now use JS symbols as weak map keys. So in the previous talk, we had map, and the weak map is kind of a variation of that, where all the keys can get garbage collected, which is nice in some niche cases, like if you want to track DOM nodes and don't want to have memory leaks. So one of those garbage collectible entities in JS is symbols, and now you can also use those as keys. And this also applies to the weak set. So I'm not sure you will use this, but might be good to know. And the last one is, again, a very small kind of quality of life change. So you can use the hashbank grammar in every single place that you can run JS. So you could have already used that in Node or Dino, just because that makes a whole ton of sense. And you want to run those as scripts. But now, if you go into your Chrome right now and import this file, whereas a year ago it would have given you a syntax error, because that's not JS. It will just import now, no problem. And that's what it looks like. So that's it. Happy coding in 2023. And see you next year in time for ES 2024.
No. Wait. Can you hear me? Can you hear me? Ah, you can hear me now. So, who's asking the question? Is it Krzysztof Wojnarowski? Krzysztof Wojnarowski from Box has a question to you.
Hi, this is Krzysztof Wojnarowski from Box. I got a question regarding this copy of an array that is like reversed. Is it a deep copy of an array or just...
No, I think that works exactly like the spread operator. So that's just the shallow copy.
Okay. Disappointing, but thank you.
Yeah. I think from ES 2022 or 1, you can use structured clone to get that deep copy. So combine those, still manual.
Are there any other questions? No questions. Thank you very much, Mio.
Thank you.
Okay, so because Barry had to go, I will finish the event and I will tell you something interesting. WarsawJS is also organizing something that's called Confront AI. Do you remember Confront.js? Was there someone at Confront.js? Oh yes, some people were. So actually we also started an AI meetup on the 4th Wednesday or last Wednesday of the month. And on 31st of May, so the day before the Day of a Child, we're having an event on parenting in the age of AI. And there will be a discussion panel, and we will have some talks, and it's going to be at CIC Warsaw. I would like to tell you about this event. You can join it as well. And it's on Confront.ai. And besides, we also plan the full agenda for 104th event. And we will have Michał Warda, how to create a web game in 2 days and make $2 out of it. Jakub Pawlak, is Michał Warda here? He spoke here. Last time when WarsawJS was here, he was speaking from here, but he's not today with us, unfortunately. And Jakub Pawlak from BC is also going to have a talk, and Jakub Wąsowski, AI-powered code reviews. So suddenly the tracks of AI and JavaScript are connecting somewhere, and yeah, we're having it. So yeah, so actually the tickets are already available. I think Maciek already announced the event on Facebook, and yeah, and I hope you're going to be there on 14th of June next month. At BC Warsaw. So thank you very much, and see you soon. Thank you.